Lab Guy here. This video is called Too Many Irons in the Fire. So let me bring you up to date. We're still on a 32 line mechanical TV craze. We are examining various motor options like perhaps laser printer polygon mirror motors like these here, which are driven with pulse width modulation. So I bought a pulse width modulator on eBay. It has a variable frequency and variable pulse width. I have this motor running fairly reliably. This one, I believe I have the enable line floating. It will run, it will stop, it will run, it will stop. This is the scanner out of a VHS VCR I scrapped recently. It's the entire head motor. The video heads are on there. We're not going to use the video heads. We're going to use the motor. It's an electronic motor. It has 6 wire connections, which I haven't worked out yet. It's got the motor driver chip. Like the others, I believe that it gets 2 DC power supplies. One is the motor coil power supply. The other is the chip power supply. And a pulse width modulated drive. And with 6 pins, there's probably a couple of feedback signals going back down to the VCR electronics, now history, and or an enable pin coming up to start the motor spinning. This spins at 30 revolutions per second in its normal operation, so I know it's up to the job. The board is removable so that I can attach a NBTV disc to the top of this scanner head drum. So this will be my new, possibly one of the motors I use for the NBTV television, which runs at 12.5 revolutions a second. That should be no problem. And I have an idea for 30 revolutions, which I will not reveal at this time, but let you ponder what that might be. You may have seen this critter in oh, come on. Okay. It wants to be a hard case. Okay. You've seen this critter in earlier videos. This is also mechanical TV oriented. Today I'm going to go ahead and build the case to hold it in this metal box down here. This is a James Millen 90901 1-inch oscilloscope subassembly from the early 1950s, if not the late 1940s. It uses the 1CP1 CRT, and this will be a 32 line CRT televisor in the future, but I want to go ahead and get this pile of parts that I've been collecting all integrated together so that it's a smaller pile of parts that's all integrated together. My room is running out of room, and that is where we are at. So today we're going to punch this metal box to accommodate this template, this footprint, and to hold this scope inside here. And like I said, get it out of the way and provide it with some protection. It's been sitting on the top bookshelf where the next earthquake here in Silicon Valley could knock it to the floor and of course render it non-recoverable. So we're going to go ahead and put it in this case so that if it drops any distance, it will be protected, and a device like that should survive, you know, a 4 or 5 foot drop, though we're onto carpet, though we're going to do everything we can to avoid that. So to start with, we've got to begin by drilling holes. As you can see, I have already marked the positions of the CRT opening and the 3 knobs and the 2 mounting screw holes. So we will start by drilling out the smallest holes first, and then we will enlarge the center hole here and use a Greenlee punch, which is a special punch for punching sheet metal and making rather large holes. My step bit doesn't go large enough to do this job today, so we're going to resort to a Greenlee punch. And as you can see, this bolt is well, it's very masculine. So let's proceed now and get on with getting this box prepared. So first we need to center punch some holes. Old lab guy is blind, so he'll put on the nerdo-visor. Some other news for you. I have placed an order for a new computer this week to the tune of $1,500. A really nice 3.6 gigahertz Pentium i7 processor, and lots of RAM, a nice new hard drive, solid state drive, and so on, so that we'll get beyond the problem. My computer, which is a name brand, I don't want to tell you the name brand, but the initials for that name brand stand for high priced. That brand of computer is notorious for driver issues. This machine has never, from day one, ever had audio input capability. The sound card the audio cannot get from the inputs of the sound card through the BIOS. It's blocked at the BIOS level. It is impossible to record audio from a webcam, from the audio cards. I bought the computer from the bargain bin at Fry's Electronics as a super gaming machine specifically to play Fallout 4, and which it does well, but apparently whoever had purchased it initially for a gaming computer probably found that their headset didn't work. They were not able to use voice communication with other gamers for online gaming, which is not my preference, so that was fine with me. I didn't consider it a showstopper. As far as dubbing my audio in my videos, the workaround is to just use one of these camcorders on the side, kind of like it is now, and do my narration, and then extract the soundtrack from this video and drop it into my video editor and use it that way. So that was the workaround. Won't have to do that anymore. I can use my good microphone and give you too much bass. Those kind of tabletop microphones come through YouTube. I've seen this on other channels. They've got really good low-end response, so they're kind of bassy and annoying. Okay, let's get on with this piece of metal. And the first thing we want to do is to center punch our spots. We don't want to bend our metal up. There you go, there it is. What you do is you find yourself an old book and you read it. And if it's a real stinker, as this one was, the movie was very good, the book sucks. It's called Make Room by Harry Harrison. The movie Soylent Green with Charlton Heston and Edward G. Robinson was awesome. It's, it's got its issues, but compared to this book, oh my God. Anyways, this book was so bad that after I read it, you'll notice it has become my drilling pad to make sure that no one ever insults their eyeballs again. Looks like it's been shot up. On with the show. Okay, so this will help put backing under the metal here so we don't cave the metal in. Can you see? Okay. There we go. Now back to punching. This is a power punch. Get one. They're wonderful. There we go. Oh, I missed. I'm off center there, buddy. We don't like that. We can over drill the hole. There we go. That's better. Okay. Now. Oh, man. That jumped. Well, we can over drill that hole too. These holes will be hidden behind that Bakelite Eustachian, however it's pronounced. Faceplate, front panel. All right. Goodbye, Harry Harrison. Yeah, not a good book. Half of the book is the movie, and then from the middle on, it sucks worse than Deep Space. That was my book report. I'll probably get sued. Oh, gonna need it. Gonna need it back. Sorry, Harry. Sorry, Harry. Alright, so we'll start with the two mounting holes. Everything else hinges from there. So we grab some drill bits and we size them to the hole. Too big. I thought it was a 1/8. I work in imperial units because, well, I'm an American and we use imperial units here. Okay, I'm going to use 1/8, which is a little bigger, which gives us some play. All right. Back to the book. All right. Let's get you a little closer. Ah. Close enough? Good enough. All right. This is what the punched marks look like. And we've caved in the back of the metal a bit. Not real happy when it does that. We can bend it back out. There we go. All right. First two holes. It walked. They always walk. There we go. Alrighty then. I don't want to get any chips on my floor. I've lived in this room, which is an old living room, a family room on this house, which has been made into a small suite. And I've lived here for 5 years, and I'm proud to say that if there's any chips in the carpet here, you can count them on one hand. All right. So let's see our screws. Put that in there. Where's the other one? Oh, he's hiding, is he? Okay. Hold the bus. Nothing goes until we find that other screw. There he is. He's hiding under a post-it. Okay, those two holes line up. So our front panel is in place. Very good. Arf, arf. Many of you will recognize that as a Frank Zappa reference. Okay, that's just a center starter hole on the main hole for the CRT. Now, the next holes that we want to drill are these holes that the pots come through. These 3 holes here, here, and here. Let's see. I should have drilled those with the smaller bit. Okay. It says 19/64. It won't go through. That's big enough. We want the hole behind to be a little bigger. So 19/64 is our guy. But we need to drill starter holes. Anyway, so back to, yes, my 1/8. So we'll drill 1/8 inch starter holes. Watch those chips. Okay. Okay. Chips. Watch those chips. Alrighty then. 3 starter holes for the pots. Oh dear. I didn't stop to think about which way is up. Oh no. Oh no, 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 no. Okay. Yeah, we put it on upside down. We drilled the holes wrong. However, since there's 3 holes, one of them's covered up, that'll solve that problem. Let's fix it. There's always a way. Alrighty, this is right side up. Frag maggot. Watch your language, lab guy. Sacre bleu. with all apologies to my French viewers. Okay. Let's see. Alrighty. Where there's a will, there's a lab guy. Oh no, a dead guy. Okay. Power punch. Okay. Boy, that sucker took off and walked. Saw that one flinging chips. I have a office style carpet floor protector underneath the workbench down here. So we're good. Okay. Now we go to the bigger bit. And in that case, we will move the garbage can down under there and hold it between our knees so that any chips that come off of the edge here go down into the garbage. Okay. Uh-oh. That dang torque thing likes to move. Okay. Alrighty then. So, shall we mark them? Which one's which? Since this is right side up with the top open, it should be that one, and that one. We do not want that one. We leave him alone. Okay. Low speed. Big bit, low speed. All right. Very good. Now, we've got the opening for the pots. Where's that thing? There it is. Alrighty. So the 3 openings for the pots are drilled through, and now we'll use this bit to do a medium size hole for the center, because we're going to have to work our way up. You can't drill a giant hole right away through sheet metal. This stuff's too thin. Alright, so since we have this medium sized bit put in here, and you can see that compared to the bolt that we're going to use, this is about half the diameter. So we're going to drill this a couple of 3 times to get there. I'm sure the largest bolt in the largest bit in my drill bit box is not big enough for that bolt. Not even close. But where there's a will, there's a dead guy. Alright, next size up. There we go. And we keep going. Okay, come out. Alright, that is a 3/8 of 1 inch hole. And we're getting there. Okay, and at this point, we now resort to our step bit, which will now get up to the point where it's big enough to accept the punch. And it's quite a ways up. Let's see. It's around 3/4 of an inch, which is 1, 2, 3, 4, 4th ring down. Okay, I think. Okay. Alrighty then. Let's check the time. I have vegetables cooking in the oven. Okay, backing out, moving it. We're now going to be using our step bit. These are very handy too. You can get these at Harbor Freight. They're pretty cheap. Not just because it's Harbor Freight, but the budget of a project doesn't matter, but Harbor Freight can help. Okay, so now we brace this and hang on, because these things like to rip out of your hands. Just like that. They like to rip out of the chuck too. We are in forward, right? Yep. Wow. Alright. Oh yeah. Alrighty. So, first thing I want to do is sweep my chips, move my motors, keep all the sensitive stuff out of the debris field. Note that I work inside of this tray. It keeps all my chips and dirt on my workbench where I can manage it, and I clean this out as necessary, sometimes 3 or 4 times a day, sometimes once or twice a week. I know I have a heartburn. There it is. Okay. Alright, put these chips over here out of my way. I'll probably put my elbow in them, but there we go. Alrighty. Next, we want to punch this hole. So, this cutter cuts in to this cup as it goes through the metal. You can see it's got some star-shaped points as it cuts, and we want this cutting face on the inside of our box because it will leave a dirty black ring, and so that is the way we will assemble it. The cup goes on this side. Note the thrust bearing on the bolt. Well, that's going to make it difficult. I don't know. Okay, that's fine. I used a similar bit to this 5/8 diameter for punching the hole in my iconoscope camera case, and I paid $65 for that bit, which when I did that part of the project I called it the $65 hole. Now I'm centering this up using the 4 points, putting them on my 4 cardinal reference lines so that we're reasonably well centered. And now hopefully this crescent wrench opens up big enough. It does not. Okay, well, there's always channel locks. That works. Oh, if you turn it the right way, it works. Now I gotta check that my blade hasn't moved. And now we're cutting a hole. Size. there. You see how it works? Inside bit, outside bit, thrust bearing and bolt. We're almost there. These dang things are expensive. I think I'm through. Oh yeah. And we're all the way through. Oh, a wise guy, eh? No worries, we'll get it. The inner bit is stuck, but here we go. These things are fun to use, but they make your fingers all grimy with the grime. And here we are. All right, there's our inner piece. He found inner piece. My friend Jack over at Vintage Electronic Geek, in one of his videos, he found Jesus. I found the inner piece. If you want to know what I'm talking about, you'll have to go watch his video. Now get out of here. What the heck over? There it goes. It's going to either go all the way through or come back out. Come on. There it comes. There it comes. Hello. Hello. One of my roommates. All right, we are through. All right, greasy tool to the side. And this. And we shall see. All right, a little cleanup on these holes. It's actually on the inside. Some of these chips, and we get the oscilloscope, and he goes, oh, everybody wants to join in the fun. Oh, don't tell me they don't fit. Okay, I won't tell you that.
It's a nice day today.
Yes, it is. Good day for shooting a video. All right. Okay. Not biting in. What's the problem? Oh. Okay. That's interesting. Here it is. Okay, see, I have a set of these. So we put them away. And then They're not in my way. I don't know where I got those. I don't think I paid anything for them. Man, sometimes you can get a good deal on things. Those things are hundreds of dollars. All right, now we need, I need the drill back, don't I? Got ahead of myself. Okay. So we need to drill out the control holes. Okay, what size did we use? I think we used 19/64, right? Yeah. Let's drill them out to, I don't know, we'll make them a little bigger. We'll go up 2 sizes. All right. Watch your knuckles, Rich. Watch your knuckles come off. Come on. Oh. Oh, come on. Okay. Sometimes you just want to start screaming at your tools, but then other people think you're crazy. But we're not crazy anymore. We used to think we were schizophrenic, but we're much better now. Honest. We used to hear voices. I didn't hear that. The shadow did. Okay. Alright, that's not working. We're going to probably have to hit that with the X-Acto knife. Just knocking off the edges here. There we go. Alrighty. I'll have you know that bomb building class is canceled today. Alright. You gotta keep it clean. Actually, you want to keep these aluminum boxes looking good. Alright. It's right in front of me. The headband on my visor here has become loose over time. And it likes to drop down over my eyes. Wow. Oh, that's not good. I see. There's two more. There's two more screws for mounting this. Ay, ay, ay. And they're the dreaded straight head screws that I despise. I'm a Phillips head kind of guy. I like Phillips. Wow, you lay it down, it starts running away. Okay, and we'll try this again. Get in there. Ah, now we're in there. And yes. So uno, that's a dos. Hey. What do you know about that? Huh? Is that downtown? Just like downtown? That didn't take very long. I love aluminum sheet metal. Some of the boxes they make are made out of a casting. I'm not as fond of those. I can work with them. They're a lot more work to make holes. And for instance, the Greenlee punch would not work with that. Okay, the pots turn freely. Good. So now is there room in there for me to get in my circuit boards and the little power supply I'm going to need to power this. I'm going to need a sheet of mu metal. I do have some. I'm learning about those magnetic fields, you know. I also have some shielded oscilloscope transformers that will work. Alrighty. So, at this point, we're in very good shape. So I believe that this will be the conclusion of today's video of what has Lab Guy been up to. We're still working on those mechanical television projects, 32 line, NBTV standard. We're going to look into some mechanical solutions. We're going to look into some electronic solutions, and so on. So, hopefully soon I will have developed a method that allows us to photograph these without flicker. That's a future project. You know how when you watch mechanical TV on YouTube, because the cameras are either 24, 25, or 30 frames, the 12.5 frame per second mechanical TV looks like crap. Well, we're going to find a way to fix that. So, here you go. Yet another electronic project started. Let's see how many years before we finish this one, okay? So, thank you for watching. If you liked the video, tell your friends. Be sure to subscribe. Click the like button. All that good stuff. And until next time, Lab Guy out.